M1 Kinematics Example 14. Another example of motion under gravity. This time we're given slightly different information. So we're told that the particle is projected vertically upwards from a point O with speed u, and the greatest height reached by the particle is 62.5 meters above this starting point. Now, if we imagine a ball being projected vertically upwards with speed u, we know that u is positive, it's going upwards, and so the acceleration due to gravity would be negative because it's towards the ground. And we also know that the greatest height is 62.5. Now remember what happens when something reaches its maximum height. Not only do we know that that's 62.5 meters, but we also know that at that instant, the particle will come instantaneously to rest. In other words, at that instant in time, its velocity is 0. So using this information, again, choose your identity. V squared equals u squared plus 2as. V is 0. Use the thing we want to know. 2 times a times s. Okay, rearranging that, let's just quickly work that out. I think that works out to be 1225 in that bracket. So if we bring that over to the left hand side, 1225 equals u squared. So what does that tell us? That tells us that u is the square root of 1225, which happens to be exactly 35. So the particle is being projected upwards with a speed of 35 meters per second. So that was part A. Part B asks us for the total time for which the particle is 50 meters or more above the origin, the starting point. So here's where we're starting from. We know that up here is 62.5, so somewhere sort of round about here is the 50 meter mark. So the ball will come up, it'll go through there, and then it'll come back down again and come back down to where we started from. So for a certain period of time, partly on the way up and partly on the way down, this particle is above 50 meters. So we need to work out when that happens. So we know that our starting speed is 35, our initial velocity, that's upwards. Our acceleration due to gravity is in the opposite direction, that's downwards. And we know that the point that we're interested in is 50 meters. That's the displacement. We're interested in the time. So using S equals ut plus a half at squared, we've got 50 equals 35t, and then remember half of a is minus 4.9. So it's another one of those quadratics. Bringing everything to the left-hand side to make it positive, and then that will be a negative 35t and a plus 50. The same as on example 13, this is not something that I envisage is going to factorise, so I'm going to use the quadratic formula. Again, I'll go through this pretty quickly. So it's minus b plus or minus square root of b squared, so that's minus 35 squared, minus 4 times a, which is 4.9, times c, which is 50. All of that divided by 2a, which is 9.8. Pause the video at this point, work that out on your calculator and see what you get. Now in this example, we need to keep the full values, so try and save these in the memory of your calculator. 5.1686, keep that one in your calculator, and if you do the minus, you get 1.9742, keep that in your calculator. Why am I suggesting to keep them in your calculator? Well, if we look back up at the question, scroll back up, find the total time for which the particle is 50 meters or more above O. So we've just worked out that the first time it hits this 50 meter mark is about 1.97 seconds. It keeps going up to the top and then it comes back down and it hits that 50 meter mark again at 5.16 roughly seconds. seconds. So the period of time it's actually above is 5.1686 minus 1.9742. That's the period of time that it's actually above the 50-metre mark. And if you work that out, that works out to be 3.2 two significant figures.